All right.
Do you have any cough drops?
On page 68, what we're going to talk about, or we're going to focus on today, is called a focus. Okay? It's called the focus and directrix of a parabola. And just so that you guys know where they're at and how to find them, the parabolas today are not just going to open up and down. They're also going to introduce you to the ones that open left and right. There's two different things that I'm going to show you today. Okay? The first type, or just so that you guys know what things are. If this was a parabola, okay, and I'm not going to put it on any axis or anything like that, right about here, that dot right there is known as a focus. And then this distance away here and the same distance down here would be this imaginary line called the directrix. Okay? So just so that you guys know, those are some of the key terms that we're going to talk about on this, or in this section. They're going to talk about those two parts. And we're going to find those in some cases, and then we're also going to use them to help us find equations. On what they call it for this, when they say a parabola can also be defined as a set of points blah, in a plane are equidistant from a fixed point called focus and a fixed line called directrix. Now that's the official definition of them. Now, what I equate it to a lot of times is in geometry you guys used a compass, right? The device used to make arcs, not circles, but they make arcs. If you were to put the pencil point right here at the focus and then the pointy part right here at the focus and the pencil part down here and swing that arc down there, that would be the example of what a focus is that it would be that certain distance away. Okay? The directrix is like this imaginary line that says you cannot pass here. Okay? So that's kind of what it is, like a electric shock fence for a dog. When you put that shock collar on it, that they can come right up to it, but they cannot touch it. That's kind of the same kind of concept. All right? What we're going to do is, given those two things, we're going to come up with the equation of the focus. So the first thing that we're going to do is I'm going to give you the focus and the directrix, and then you're going to use what they call the distance formula to find them. Do you guys remember what the distance formula is? No? We did it in chapter 1. x2 minus x1 squared plus y2 minus y1 squared. Okay? So the first half of your assignment today is going to be using this. I'm going to give you a focus and I'm going to give you the directrix, and then you have to come up with the equation of the parabola based on those two pieces using this equation. Okay, so this distance formula is going to give you what our answers are going to be. So, after I get that down, or you guys get that down. By the way.
Yeah, I got it.
Sure.
Yeah.
Okay, so what they're going to do is they're going to say your focus is at 0, 2, and the directrix is at y equals negative 2. Okay? So that's what's going to happen. Now, for this particular thing, I don't know, maybe I'm just like that type of person because I am more visual. I do like a little picture just to kind of see what's going on. Do you have to draw a picture? No. But I usually do just so that way I have an idea of where it's at and what's going on with it. If I put the focus at 0, 2, that means that I have a dot right here. And if I put the directrix at negative 2, that means it goes down like this. And it says y equals, not x equals. Correct?
Yep.
This parabola is going to open up. And the reason why I know it's going to open up is it's kind of like the directrix is this line that, hey, don't come this way, go the other way. All right? And the focus is like, yeah, come towards me. So that's what it's saying, is that you always open up towards the focus, no matter where it's at. So if you've got the directrix running north and south, then the parabola is going to open to the left or to the right. Now what's going to happen is you're going to have something that comes in here like this. And what you're going to find is you're going to find this ordered pair that's also the distance from this ordered pair. That's what you're going to have to find. Okay? So this ordered pair was at 0, 2, and this ordered pair is at some x and negative 2. How did I get the negative 2 for that bottom point? Because what was the line? Negative 2. The directrix is at negative 2 for the y. Do you know what x that occurs at? No. Do you know what this point is at x and y? No, you don't. Okay? So what should happen is this. This distance that I'm going to mark in blue, this distance right here, should be the same distance as the one I'm going to mark in red. Those distances should be equal. Do you know what ordered pair that lies at? No, you don't. So you're going to find that. How you're going to find that is you're going to use the distance formula. So watch what happens. The first thing that I'm going to do is I'm going to find the distance between these 2 points right here. And then the second thing that I'm going to do is I'm going to find the distance between these 2 points here. Those distances should be the same distance, right? If I said that they were the same distance, then what should I do with both distances when I get done with them? Set them equal to each other. If they're the same distance, you might as well set them equal to each other. So here's how you work it. I need another slide because this is going to take up some room. 0, 2, and xy was the pair of blue points. Then xy and x and negative 2 was the red points. Now again, here's something that you can do. Do you have to necessarily make a picture for this? No. But for this particular thing, the 0, 2 was your focus, right? So you find the distance between the focus and some unknown point. Remember, points are ordered pairs. They're always x and y. That's why I have the x and y in blue. Then over there in red, I put the x, y, that same point that we don't know. And then I put x and negative 2 because that was the directrix line. You don't know what x coordinate that lies on. If you did, it would make it easy. But you don't know that. So that's why you put it like that. Now what Tamara set up here, and she was right, is that we're going to set them equal to each other because they should have the same distance. They should be equal. Okay? So once I put them into the distance formula, I'm going to set them equal to each other. So the first one in blue. What number is in the second x position? What's in the second x position? X. Minus what's in the first x position? 0. Squared. Plus what's in the second y position? Y. Minus what's in the first y position? 2. Squared. Equals, because didn't we say that they should be equal to each other? Can you put them equal to each other right away? Might as well. What's in the second x position for the reds? Minus what's in the first x position for the reds? X. Squared plus what's in the second y position? Minus. Good. Inserting this is one of the pieces that a lot of people mess up on because they do not put it in the right or proper spots. If you don't put things in the proper spots, you're going to be off. Okay? So make sure you're in the proper location. Now from here, this just becomes, let's simplify these. So let's start with the one in blue first. What's x minus 0? X. X minus 0 is just x. What's x squared? X squared. So that whole front part is just x squared. The second part, y minus 2. Since you don't know what the y is, here's what most of you screw up with this. You put y squared plus 4 and you think you did a great job. But when you have that binomial, that y minus 2 like that, squared, that means this. It means y minus 2 times y minus 2. And what acronym do you use for this particular concept? Starts with an F and ends in oil. Right, FOIL. Good. So first, what's y times y? Y squared. What's y times negative 2? Negative 2y. What's negative 2 times y? Negative 2y again. And what's negative 2 times negative 2? Positive 4. If I combine my like terms, I have x squared plus y squared minus 4y plus 4. That's what I have for blue. I'm going to put blue on the back burner for a second and just let it simmer. We need to go do the x's now, or the red side. What's x minus x? Zero. Right. Something minus itself is always 0. So what happens with that first parentheses in the red zone? Yeah, this whole thing just goes away. Or you could put 0 squared there if you'd like. But realistically, 0 squared is just going to go away. I have negative 2 minus y squared. What do I have to do for that? FOIL. Now, there is a little formula for it, but here's what I found. Most students cannot manage it, so I suggest always just write it twice and FOIL it. What's negative 2 times negative 2? 4. What's negative 2 times negative y? Plus 2y. What's negative 2 times negative 2, or negative 2 times negative y again? Plus 2y. And what's negative y times negative y? Plus y squared. When I combine like terms there, I end up with y squared plus 4y plus 4. Because what happened to the 0? Is it really there? No. Now, once you get it to this phase, here's what's going to happen. Do you see how I have square root in this problem? If the left side equals the right side and vice versa, could I just get rid of the square roots? Or better yet, in order to get rid of square root, what's the opposite of square rooting? Say it, Chandler. I think you're going to be right. You don't know? Chicken. Anybody know what the opposite of square rooting is? Squaring it, right. Why didn't you say that the first time?
I had it in my head.
Okay. So, if I square both sides, what happens with my square roots? They go bye-bye. So I have x squared plus y squared minus 4y plus 4 equals y squared plus 4y plus 4. Now, if you have something on the left side that matches identically to something on the right side, what's going to happen to it? If you add it to one side or subtract it to the other side or something like that, what's going to happen to them? They should cancel. Is there any piece up there that you see that should cancel? The 4s should go away. Right. If I subtract 4 to both sides, they gone. Is there anything else that should magically disappear? The y squareds should go bye-bye. If I subtract y squared to both sides, they're gone. Is there anything else that should go bye-bye? No. Most people screw up. If you screw up one sign right now, you would actually, some of you would try to cancel out the 4 y's. But one's a positive and one's a negative, and that doesn't work. Okay? So, here's what needs to happen. You need to get the y's and the x's on opposite sides. Okay? So what side do you want to move stuff to? The x's are already just on the left side. But I got y's on both sides. Which side do you want to move the y's to? You're going to add 4y to both sides. Good idea. I get x squared equals 4y. What you want to do for this is you want to get the one that does not have a squared on it by itself. So in this particular case, we're solving for the y. Yes, Hunter?
It should be 8y.
It should be 8. Who did that? Who only put 4? Sam. Okay. Thanks for pointing that out, Hunter. Good job. Okay. So for this particular thing, what you want to do always, once you get it to this phase, you want to solve for the one that has not squared on it. Sometimes it could be the x and sometimes it could be the y. Okay? So in this particular case, what are you going to do to both sides? Divided by 8. Divided by 8. And that, I know, can't really fit because these problems get to be really long. Now, I'm going to rewrite it like this. Dividing by 8 is the same as multiplying it by 1/8. Okay? Dividing by 8 and multiplying it by 1/8 are the same. So I'm going to write it as 1/8, and you will see why when I do the second half of your assignment today. On the first half, this is what you have to do. All right? They're not going to be so user-friendly. This is what you have to do to figuring out the first half of your assignment. Okay? Do you want to do another one? Yes? Okay. So, on page 72, pick a number from 3 through 10. Tamara? 6. Says y equals 7. And the focus equals 0, -7. Okay? So, here's what I'm going to do. Do you want me to draw the picture at all? Yes? Okay. So I'll use one slide to do the picture and one slide to do the problem. If I draw the focus, where should the focus be? -7 where? Down or to the left? Down. 1, 2, 3, 4, 5, 6, 7. Make dot. And the directrix should be up 7. 1, 2, 3, 4, 5, 6, 7. What kind of parabola is this going to be? One that opens up or down, left or right? Down. How did you know, Petey, that it opened down? Oh, that's ugly looking, but you got it. Because the directrix is on top, so therefore it goes down. Okay? So for this particular thing, it goes down. Now, what you're going to find is some arbitrary point that's equidistant here as it is to here. Now, I know my picture doesn't look very whatever, but it's not drawn to scale. I did a horrible job drawing the parabola. Okay? I blame Sam. Huh?
Just like pick a spot then?
Yep. And that spot, Taylor, is known as the point XY. Okay? Now, the bottom point, the focus, was 0, -7. This is one of the distances you need to figure out, is that group. Now, for this directrix point right here, you don't know what x that hits at, but you know what the y hits at because it's the directrix line. So when they give you the directrix as y equals 7, oops, I don't put 0 there. It's x and then it's 7. And the reason why it's 7 there is because the line is at 7. That's why that goes there. If the line was at 5, I'd put 5 in that spot. Or if it was at 2, I'd put 2 in that spot. We haven't picked one that had x's. If it said x equals, so we'd have one that opens to the right or to the left, then we would actually have x was the number, and the y would be the not, I don't know. Okay? So then we have to find the distance between these two groups. Okay? So those are the ordered pairs that we're going to use. So I need a new slide because that ain't going to fit.
Does it matter, like, on the bottom, like, the XY? Does that have to be X and HY?
On that, no, because we're going to get a negative number out of there anyway. So don't worry. It's a y. Doesn't matter if you put positive or negative there because of the fact that it shouldn't. The y will be negative eventually. If you put negative y and then you get a negative answer, well then that turns into positive when you plug it back in. So it's always just x and y. Okay? Good question though. So the first side, 0 and negative 7, x and y. And then what was the other side that we're using? X and y. And then x and 7. Okay?
Is the X7 then like
From the Directrix? Yes. Now, realistically, when I asked Chandler got it right when he said square both sides when we did the square root of that part, can we get rid of that altogether? Did we ever even do anything with the square root at all? No, we didn't. Is that okay if we just get rid of it and not worry about it? Sure, it really is. So, what is the second x on the black group? Minus 0 squared plus, what's the second y? Y minus negative 7 squared. Do you want to clean up the black side first and then do the red side, or put the red side in there now? You want to clean it up first? Okay. What's x minus 0? X. What's x squared? X squared. Good job. That wasn't so bad. Plus. When you have two negatives side by or in front like that, so y minus negative 7, what's two negatives do? One big fat positive. What's the squared do? You have to FOIL it. What's y times y? Y squared. What's y times 7? What's 7 times y? What's 7 times 7? Awesome. And if I clean everything up, I have x squared plus y squared plus 14y plus 49. Is everybody okay with the left side? Now, let's go do the right side. What is the second x? What is the first x? What is the second y? Minus squared. What is x minus x? 0. What is 0 squared? 0. Hey, just so you guys understand this is two problems now that happened, right? But these open up and down. The x is canceled on that one. What happens if they open left and right? The y's will probably cancel with one of the groups. Yeah, awesome. So in the back half, we got 7 minus y times 7 minus y. What's 7 times 7? 49. Good. What's 7 times negative y? Negative 7y. And what's negative y times 7? Also negative 7y. And what's negative y times negative y? Positive y squared. When I combine like terms, what is 0 plus 49? 49. What's negative 7y minus 7y? Negative 14y. And what is y squared? Y squared. So again, what I did was the x's canceled and I FOILed out the back group. And that's what I got. On the first side, the x's don't cancel and I FOIL out the y group. When you have it going the other way, you're going to FOIL out the x group and the y's are going to cancel. That's what's going to happen. Okay? Now it's time to go from one side to the next. As you guys noticed on the last problem, what's going to happen with the y squareds? They cancel out. If I subtract y squared to both sides, they gone. What other piece is going to go bye-bye? The 49s. If I subtract 49 to either side, they gone. So what you need to figure out is you need to put either all the y's to one side and all the x's to the other side. What side do you want to move the y's to? To the right? Sure. Because the x squared's already on the left. You might as well just move it over that way. So minus 14y. And let's see if Sam can figure this part out today on this one, since I'm blaming him for screwing up me not adding the last one right. What's negative 14y minus 14y? Negative 28y. Now what you want to do from here is you want to solve for the one that is not squared. Which one's not squared? The y. So how do I get rid of times by negative 28? Divide by negative 28. And when you divide that, that's what it looks like, but I'm going to rewrite it as negative 1 over 28 x squared. You will see why I do that on the second half of the assignment. The second half of the assignment is way easier than this. This is the hard ones. Okay? I promise. You have to be methodical in your multiplying. If you're not, you're going to get it wrong. Be very, very careful that you can add and everything else. Like I didn't on that one and I blamed it on Sam. If I didn't add right there, we would have been off. Okay? That's how you do the first half. The second half, like I mentioned, is a lot easier. I promise. Here's how these parabolas look. If a parabola opens up or down, okay? So I'm just giving you the visual part for up and down. When they open up and or open down, the formula looks like this. Y equals 1 over 4p x squared. Okay? Where the focus is going to be at the order pair of 0 and whatever is in the p spot. And the directrix is always going to be y equals negative whatever's in the p spot. Okay? That's if they open up or down. So if you notice the ones we've done so far when we found the equation, that's what we had. Was the focus 0 and some number? Yep. Was the directrix y equals some number? Yep. That's what we had. Now if they open to the left or to the right, now it's a little bit different story. You haven't seen these before. Now it's x equals 1 over 4p y squared. So notice the difference. If the x is squared in the problem, then it opens up or down. If the y is squared, then it opens left or right. Okay? The focus now is going to be where x is the p and y is the 0. And the directrix is going to be where x equals negative p. Those are the two types of problems that you're going to have, or two different types that you're going to see. Not necessarily a negative, but if you have that, whatever that p is, when it's if it's two negatives in there, it would make it a positive. Like that last one that we used, the directrix was positive 7. That's because that p was negative 7. And so when you put it in there, two negatives make it a positive. Okay? Now, here's the way this one's going to look. It's going to say something like this. It's going to say negative 4x equals y squared. And what it wants you to do is identify the focus, directrix, and axis of symmetry. And then you're going to use that to help you sketch the graph. Here's how you do it. The part that's not squared, you got to solve for that letter. What part is not squared in this problem? X. Solve for x. How would I get that all by itself? What? Divide everything by -4. When I do that, I get x equals. Now, when I divide it by -4, as I heard Taylor tell me, I'm going to rewrite that as not dividing by -4, but actually multiplying it by 1/4, or -1/4 in this problem. So -1/4 y squared. So again, dividing by a fourth, or dividing by -4 is the same as multiplying it by -1/4. Okay? Why did I write it like this as compared to just putting it divide by -4? Because now this looks like one of the equations. Okay? So which way does this open? Left or right, up or down? Left or right? How'd you know it went left or right? Because the y is squared. Right. Now what you need to figure out is what number is in the p position. So here's how you do that. On this previous screen, here's where the p was at, right there. It was 1/4p. So the number in front, you're going to set equal to 1/4p. So 1/4p equals -1/4. That, my friends, is called a proportion. How do you solve a proportion? You cross multiply and then you divide. Exactly. What's 4p times 1? What's 4p, or no, 1 times -4? And then what? What's -4 divided by 4? -1. So what does that number tell us? That's going to tell us where the focus is, the directrix. It's going to tell us everything we need to know. Okay? Now, from here, which one does it model? Does it model the ones that go up and down or left and right? Left and right, because the y was squared. So on left and rights, the focus is at -1, 0. And the directrix was at x equals -1. So let me put that on my graph. Well, that was pretty straight. Where would -1, 0 go? Oh, hold on, I messed up. Now I got it right. The directrix is not at -1. The directrix would be at +1. Why was it +1, not -1? Because when I put negative in there with the -p, that two negatives make it a +1. That's my fault that I messed up. So how do I draw the focus? Nope, not down 1. Left 1. Make dot. The directrix is to the right 1. Now, just so that you guys have this in your minds a little bit. The focus and the directrix are on either side of the vertex. Remember what the vertex is? We just took a quiz on that stuff. That was the middle, right? The focus and the directrix are right in the middle. So what dot would be right in between that dotted line and the dot we have on there? 0, 0, right? So this one's the focus, this one's the directrix, and this right there would be where the vertex is. So how do you open a graph that goes left and right? You make it look like a parabola that goes to the left or to the right. Why did I know this one goes to the left? You go away from the directrix or towards the focus, whichever way you want to call that. That's how you do the second half of your assignment today. Okay? Now, notice what I put on the graph. I put the F, the V, and the D. I put the focus on there, I put the vertex on there, I put the D on there. That's what I did. Make sure you label those. Okay, let's do another one just to make sure we got it. So 13 through 20. Allie, pick a number from 13 to 20. 11. Okay, can I ask you to try again? Because I said from 13 to 20.
Oh, that's on 15?
15. Okay. 15 says x equals negative 1 over 20 y squared. Is this one already set up for us where the x or the y is already solved for? Yes, it is. So notice on this one I did not have to multiply or divide to begin with. I could just start. How you start these again is you set the stuff that's in front of your squared equal to 1 over 4p. It's always equal to the 1 over 4p. Once you get it as x on one side, y squared on the other, and the x is all by itself, then set it up like this. How do I solve these again? Yep. How do I do that? 1 times 20 is what? 4p times negative 1 is what? Now notice, when I said that out loud, I only did the negative for one of them, not both of them. When you do the negative in there, or if the negative is in the problem, it's either one or the other, it's not both of them. Okay? Now, how do I solve for p? What's 20 divided by negative 4? Negative 5. Is this a parabola that's going to open up or down, left or right? Left or right? How did you know? Because the y is squared. So if the y is squared, then the focus is at the x spot. Negative 5, 0. And the directrix line, remember, was x equals negative p. Negative, negative 5. What's two negatives make? Positive 5. And that's something I didn't show in the last one, and I almost got it wrong. So when I go to graph this, let's put our ordered pairs on there. Where'd the focus go if it's negative 5, 0? It goes left. Remember, the first number tells you left or right. Make dot. Where's the directrix at? 5 to the 1, 2, 3, 4, 5. Make dashed line. Where's the vertex at? Okay. This is nothing more than trying to cut things in half, you guys. If I went 5 to the right, 5 to the left, that's how many spaces total? 10. So what's half of 10? 5. So go 5 from the focus or 5 from the directrix. Where are you at? 0. Can I give you a little secret, but don't tell anybody? Has this been shifted anything from to the left or to the right or up or down? No, it has not. So what's the focus or vertex going to be? 0, 0, unless we shifted it. We did not shift this. This particular concept is working with the stretching and shrinking part of it. Will this get wider or narrower? If the focus is 5 away from the vertex, it's probably going to get bigger. Okay? It's probably going to come in here like so. Because of the fact that if you put point end here and pencil end here and swung that like a compass, it would be wide, wouldn't it? Wider than 1 or 2, that's for sure. Okay? Did I put the focus on there? Did I put the vertex on there? Did I put the directrix on there? Did I graph it? What's the axis of symmetry, by the way?
X.
The x-axis, which is also known as y equals 0. Okay? This is what you're going to do. The first half is doing the distance formula. The second half is just like this. Which one seems easier? Second half? So on page 72, 3 to 24 multiples of 3.